Well, it's me again, Mrs. Hoekstra. I'm working on Module 1, Lesson 15, Equations of Graphs of Proportional Relationships Involving Fractions. And my essential question today, what is a benefit of a graph of proportional relationships involving fractions? All right, so we're kind of reviewing back through almost the whole entire module with this one, which is good because we're heading into our test. What is... Sorry about that interruption. What is a benefit of a graph of proportional relationships involving fractions? Okay, so we've got a mom who is going to be in a race, right? She's doing a 10K. Sam's mother has entered a 10K race. Sam and his mother want to show their support of their mother, but they need to figure out where they should go along the race course. They also need to determine how long it will take her to run the race so that they will know when to meet her at the finish line. Previously, his mother ran a 5K race in a time of 1.5 hours. Assume Sam's mom ran the same rate as the previous race in order to complete the chart. All right, so we're going to come down here. We're going to fill in this chart. We know what? We know that she ran a 5K in 1.5 hours. All right. So I'm going to keep track of the time. I think I'm going to keep track of time. I don't know, maybe like every half hour. Half an hour, 1 hour, 1.5 hours, 2 hours, 2.5 hours, and 3 hours. Okay. And I know at 1.5, right, she could run the 5K. All right. So I could use that ratio, to help me figure out the others. Okay. So what I'm going to do is I think I will take and find out what that ratio is, because it says to assume that she's running at a constant rate. So we're going to do her speed, her distance divided by time is how you find the speed. Distance, 5K, 5 kilometers, over her time, which was 1.5 hours. Okay. So when she goes and runs this, let's see here, I'm going to double this because it's not legal to have that decimal in there. So that becomes 10 over 3. All right. Or we can calculate that to be what? 3 1/3. So she's doing 3 1/3 kilometers per hour. That's how fast she's going. So that helps me with this one here, 3 1/3. All right. I can just cut that in half, right? If I just cut that in half, I would get there. So if I take 3 1/3, cut it in half, it's 1 2/3. All right. And then I could also calculate, let's see, if I just go every half hour now, because I've got the half hour trend going on here. So this is going to be 6 2/3. And then if I add another half hour to that, it's 8 1/3. And then finally, the 10K. Haha, right? Which I did kind of have up there with that K equals 10 over 3. Sure enough, 10 over 3 in my table there. So what are some specific things that we notice when we put this together in a graph? Well, let's graph this first. So half an hour, 1 2/3. So it's like about there. And in 1 hour, it's at 3 1/3, about there. And 1.5 hours, I'm going to change color because I was given that data. 1.5 hours, it's at 5. And then at 2 hours, it was 6 2/3. And then at 2.5 hours, 8 1/3. And then lastly, 3 is 10, right there. And it says, what are some specific things that you notice, right? This graph is a line, and what does it go through? Yep, it goes through 0, 0. This graph makes a line, doesn't it? It makes a line that goes through 0, 0, also known as the origin. I love seeing you guys writing that on there instead of 0, 0. Shows me that you understand what the origin is. All right, what is the connection between the table and the graph? Well, all the values in the table, right, become the coordinates of our graph. The values in the table become the coordinates. They become the coordinates of the graph. Okay, so a second ago when I was graphing that, I was taking the time, right, the first part, that first column, and I made the ordered pair with time and the distance, which is going to help me here with this next question. Because the next question says, hey, what is 2 comma 6 2/3? Right? What does it mean in context? I don't want to know, oh, you know, it's 2 comma 6 2/3. It's a spot on the graph. I don't want to know that. I want to know in the context of this story problem. Right? In other words, it says it takes Sam's mom takes his mom, what, 2 hours? 2 hours to run 6 2/3 of a kilometer. Okay, that's what that says to me. And then I'm going to add a little piece to this. I'm curious if we could write the equation to calculate the distance for any distance that she races, because we're going to assume that she goes at a constant rate. So if I said, let's write an equation, right? I'm going to use D for distance. And let's do H for hours. How's that sound? H for hours. We could use T for time. So her distance that she runs is equal to, and then I like my fractions. I'm going to use the fraction form, 10 over 3h. All right, I like using that fraction that I had up here, because remember I told you all that the equation is always y equals kx. Well, I'm not using y and x, I'm just using d's and h's. But they're still going to work the same way. If you wanted to say y equals 10 over 3h, or excuse me, y equals 10 over 3x, that would be fine as well. Just make sure you tell me what the y stands for and what the x stands for. I like having the letters kind of represent what they mean. All right, let's go to the next page. Gourmet cooking. After taking a cooking class, you decide to try out your new cooking skills by preparing a meal for your family. You have chosen a recipe that uses gourmet mushrooms as the main ingredient.
Caleb Harvey, if you're in the building, please come.
Sorry for that interruption. So we're going to use these mushrooms, right? And we're going to calculate some things going on here. So you notice that starts at 0, 0. And then half a pound costs $4. 1 pound then should cost me how much? 8. Yep, should cost me 8. And if I look right here in this ordered pair, it should say 1 comma 8. 1.5 pounds is going to cost me $12. If I have $16, I can afford to buy 2 pounds of mushrooms, right? And if I have $18, I can buy 2.25 pounds. Is this relationship proportional? Take a look at the graph, take a look at the table. What do you notice? This is proportional. Why? Why is that proportional? Because it's a line that goes through 0, 0. This is proportional because the line in the graph goes through 0, 0. Goes through 0, 0, the origin. Also, the table. What do you notice about the table? Yeah, the values have a constant of proportionality. The table values have a constant of proportionality. Maybe you saw the proportional relationship in one versus the other, but make sure you can see both because, you know, I might only give you on a test, may give you one or just the other, and you'll have to figure it out. So what is the unit rate? If I only wanted to buy 1 pound, right, I've got to figure out what that unit rate is. So the unit rate for this particular problem, right, is going to be the cost, because notice cost is on the y-axis up here, right? That's my y, and my weight, that's on my x-axis. So cost over the weight. So pick any of those ordered pairs that are up there, like 4 and 1/2, right? But that fraction inside the fraction is illegal. So I'm going to have to change that. So I'm going to change the denominator to 1, right? I'm going to double that. So if I double this one, I get 8. So in other words, it's $8 per pound. $8 per pound. Write an equation. Now remember, I always say that you can write it as y is equal to kx. But a minute ago, I also told you that y was the cost and x was the weight, right? So I'm going to say cost is equal to, what's the k? Yep, right up here. There's my k, 8. And instead of x, I'm going to say times the weight. Now, that's really not an equation. That's a number sentence. So let's write it. Instead of saying cost, we'll say the letter C. And instead of weight, we'll use the letter W. Right? Cost is equal to 8 times the weight. All right. What ordered pair represents that unit rate? Well, if you remember, 1 comma R should give me my unit rate, and that should be up there. And I believe it is 1 and 8, right? In other words, 1 pound costs $8. 1 pound costs $8. All right, what does the ordered pair 216 mean in the context of this problem? What does this mean? 2 is my first value. 2 represents the pounds. So 2 pounds costs $16. If you can only spend $10 on mushrooms, right? My cost, there's the cost, is $10. How many pounds? I don't know that, right? I don't know the weight. So I'm going to use that equation from up here. I'm going to bring that down here. The cost is equal to 8 times the weight. Cost I know is 10. That was given to me just a second ago. That is equal to 8 times W, the part I don't know. 8 times what is 10? Well, that's kind of awkward to do. So what we do in algebra, right, and this is pre-algebra, so we're going to do this. We're going to divide by 8. It's the opposite of multiplying by 8. So we're going to divide by 8. And so on your handy-danny calculator, you grab 10 divided by 8, and we figure out what the weight is. And the weight in this case is 1.25, right? So I can get 1.25 pounds for $10. All right, let's suppose you're not making this meal for just your family. You're making it for like the family, all the relatives, aunts, uncles, everybody's coming over and you're making this meal, right? You need 30 pounds of mushrooms because I don't know why else you would have 30 pounds of mushrooms. All right, so how much is the cost? I don't know the cost, but I do know the weight. So again, I'm going to use that formula. Cost is equal to 8 times the weight. So cost, I don't know, is equal to 8 times, and in this case, instead of writing W, I write 30. And 8 times 3, I know is 24, so I just add an extra 0 to it. $240, that's a lot of mushrooms for 30 pounds of mushrooms. All right, that is all I have for today. Hopefully you guys understood. Have a great day.